Section 6.5 is on rhombi and squares. The definition of a rhombus is a parallelogram with all four sides congruent. So here we have rhombus ABCD, and we don't actually have a little symbol for rhombus because it would look too much like a parallelogram, so we just either write out the word rhombus or abbreviate as I did here. Now, what makes this distinctive is that all four sides are congruent to each other. So AB is congruent to BC, which is congruent to CD, which is congruent to DA. And since a rhombus is a parallelogram, all of the properties of parallelograms also apply to rhombi. That is, opposite sides are parallel to each other, opposite sides are congruent to each other, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. But a couple things that make rhombi unique are that the diagonals of a rhombus are perpendicular. So AC is perpendicular to BD, and so that's why we put this little right angle box in the center there. For every rhombus, the diagonals are perpendicular to each other. That's actually kind of a unique feature of a rhombus. And each diagonal bisects a pair of opposite angles. So for example here, diagonal BD bisects big angle B, angle ABC, so that angle 1 and angle 2 are congruent to each other. It also bisects big angle D, angle ADC, so that angles 3 and 4 are congruent to each other. But now because big angle B and big angle D are congruent to each other, angles 1, 2, 3, and 4 are all congruent to each other. And the same thing is going to be true with diagonal AC. 5 and 6 are congruent to each other, 7 and 8 are congruent to each other, and because big angle A is congruent to big angle C, angles 5, 6, 7, and 8 are all congruent to each other. Now, a square is a parallelogram that has 4 congruent sides and 4 congruent angles. Because it has 4 congruent sides, a square is actually a rhombus, because remember, that's the definition of a rhombus, a parallelogram with 4 congruent sides. Since a square has 4 congruent angles, it's also a rectangle. Remember that that was the definition of a rectangle, a parallelogram with 4 congruent angles. Therefore, a square is both a rhombus and a rectangle. So all of the properties of parallelograms, rhombi, and rectangles apply to squares. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, the diagonals bisect each other, the diagonals are congruent, the diagonals are perpendicular, and the diagonals bisect opposite angles. There's a lot going on with a square. So let's take a look at a couple examples here. Here we have quadrilateral ABCD, and we know that it is a rhombus. So number 1, if AB is equal to 2x plus 3 and BC is equal to x plus 7, we need to find the length of CD. Well, we know that in a rhombus, all of the sides are congruent to each other. So AB is congruent to BC, and it's also congruent to CD. So let's set AB equal to BC. So 2x plus 3 equals x plus 7, or x equals 4, and CD is actually the same length as either AB or BC, so I'll just pick BC because that's the easiest one. So CD is the same length as BC, which is x plus 7, or 4 plus 7, so the length of CD is 11 units. Example number 2. Find the measure of angle DEC. Well, looking at the picture, angle DEC is one of those angles formed in the middle by the diagonals where they bisect each other, and by definition, or actually one of the special characteristics of a rhombus, is that those are right angles, that the diagonals are perpendicular to each other. So the measure of angle DEC is 90 degrees. Since the diagonals are perpendicular, they form right angles, and all right angles measure 90 degrees. Number 3, if the measure of angle ABC is 64, find the measure of angle ADB. So let's go ahead and mark that in there. Angle ABC, so that's the large angle here. That's 64 degrees. And I need to find the measure of angle ADB, so that would be this one right here. Okay? Well, opposite angles in a rhombus are congruent to each other, so big angle B is the same as big angle D, so this one down here is also 64 degrees. But I also know that the diagonals bisect the angles. So the measure of angle ABD, ADB, is going to be 1/2 of the measure of angle ABC. Because ABC is the large angle, that's the same as the measure of angle ADC, and this diagonal cuts ADC in half, so the measure of angle ADB is going to be 1/2 of 64, or 32 degrees. Number 4, if the measure of angle BCD, I'm going to go ahead and mark that, BCD, so that's this large angle here, is 128. Find the measure of angle, that's BCD, find the measure of angle BDC, that's this one right here. Okay, that's what I need to find. Well, I know that consecutive angles are supplementary. So if the measure of angle BCD is 128, then the measure of angle ADC is going to be 180 minus 128, which is going to be 52 degrees. So angle ADC is 52 degrees because consecutive angles have to be supplementary, and the measure of angle BDC, which is the one I have marked in purple here, is going to be 1/2 of ADC, or 1/2 of 52, or the measure of angle BDC is 26 degrees. So here's a couple examples. Determine whether each parallelogram is a rectangle, a rhombus, or a square. And we're not going to graph them and we're not going to look at them. We're actually going to use distance formula and the slope formula. I think those are the two that we're going to use. So kind of the trick to doing this problem is to check the diagonals. Because remember, if the diagonals are congruent to each other, it's a rectangle. That was one of the distinctive characteristics of a rectangle, is that the diagonals are congruent. If the diagonals are perpendicular to each other, it's a rhombus. That was one of the distinctive characteristics of a rhombus. And if the diagonals are both congruent and perpendicular, then it's a square. So what we're going to be focusing on is what's going on with the diagonals. So I need to use the distance formula on AC, find out what the length of that is, and then find the length of BD. And then I need to find the slope of AC, and I need to find the slope of BD. So if my diagonals AC and BD are congruent to each other, there will be a rectangle. So using the program in my calculator and plugging in the numbers, I get that the length of AC is the square root of 272, and the length of BD is the square root of 68. So my diagonals are not congruent. They're not congruent to each other. Therefore, since they're not congruent, it's not a rectangle. So parallelogram ABCD is not a rectangle. Now let's find the slope of each diagonal, and let's see if they're perpendicular to each other. So the slope of AC, using the program in my calculator, is 1/4, and the slope of BD is -4. Okay, so those are opposite reciprocals of each other. Therefore, AC is perpendicular to BD, and if the diagonals are perpendicular, it is a rhombus. And parallelogram ABCD cannot be a square because, remember, in order for it to be a square, the diagonals have to be both congruent and perpendicular to each other. So this is only a rhombus. Let's take a look at another example, and we're going to do the same thing. So, given these coordinates of the vertices of parallelogram ABCD, let's determine if it's a rectangle, a rhombus, or a square. So I need to find the length of each diagonal, and I need to find the slope of each diagonal. So the slope of AC and the slope of BD. And using the program in my calculator, I get that the length of AC is the square root of 260, as is the length of BD. It is also the square root of 260. So AC is congruent to BD. Therefore, it is a rectangle. Because my diagonals are congruent, they have the same length. Now let's find the slope of each diagonal. The slope of AC is 7/4, and the slope of BD is -4/7. So AC is perpendicular to BD because their slopes are opposite reciprocals of each other. Therefore, this is a rhombus. Because in order for it to be a rhombus, the diagonals have to be perpendicular. Since it is both a rectangle and a rhombus, therefore, it is a square. And that's my final answer. Since the diagonals of this parallelogram are both congruent to each other and perpendicular, this parallelogram is a square.